Hello and welcome to Bay College's Intermediate Algebra online lecture series. Today we're going to talk about section 6.4, which is solving radical equations, equations that contain radicals. If we consider this example here, this is an equation, the square root of x equals 4. And some of you may be able to look at that and say intuitively, well, I know the square root of 16 is 4. But let's actually see why. What we can do to solve this, the property we can use, is a property we've essentially been using for a long time. What we do to one side of the equation, we must do to the other, the properties of equality. So how do I get rid of the square root? Well, I can essentially just square it. But what I do to one side, I need to do to the other, property of equality. Well, if I square a square root, I get what's under the radicand, just the x, right? And here, 4 squared is 16. So we can check that. Is the square root of 16 equal to 4? Yes, it is. The square root of 16 is 4. So this is our solution because we checked our answer. Essentially, if we have any equation, this side equal to that side, if we raise both sides to the same power, it is still a similar equation. Okay? It will contain the solutions that we're looking for. But it may also contain something called an extraneous solution. It does not create an equivalent equation, but it does create an equation that has the set of numbers that contain the solutions. It may have additional. And that's why it's important to always check your work no matter what you're doing in a math class. Let's see an example here where we end up with an equation that may have extraneous solutions. We have x equals 8. Well, we're going to do a little bit of circular math here and come back to this. But we can say, well, if x is 8, it is what it is. There's nothing really to do there. Well, we're going to do some math to it and then undo it. What happens if I square both sides? Well, I get x squared equals 64. Now, because I raised both sides to a power, it is not an equivalent equation. It's not the same as this anymore. I did something different. Now, if I take this equation and I go to solve it, well, I'm going to take the square root of both sides. To get rid of something squared, you take the square root. But when you introduce a square root, you have to always remember plus or minus. There are two possible things that will give me a positive 64. And now if we do this, if we take the square root of something squared, we just get what's under the radicand, and we have plus or minus 8. Now, notice we actually have two solutions, positive 8 and negative 8. Which one of these is the correct solution? Well, just the positive one. Positive 8 is positive 8. True statement. Negative 8 is not the same. This negative 8 is called an extraneous solution, and that's why when working with radicals and solving equations containing radicals, it's so important to check your work. So let's look at these steps here. This is essentially what we want to do when solving radical equations. The first step is isolate the radical to one side of the equation. Get it by itself. Use your properties of equality, what you do to one side, you do to the other, to get that radical by itself. Then raise both sides to the index, which that means is this is a square root, so I squared both sides of the equation. So you look at the index, maybe it's a cube root or a fifth power or something of that nature, or fifth root. Then we go ahead and solve it as we would normally to get an equation that contains the solutions and possible extraneous solutions, and that's why we have to check those to make sure which ones work in the original equation. Let's eliminate those extraneous solutions. All right, so let's look at some examples here. Here I have the square root of 2x minus 3 minus 2 equals 1. Well, step 1, isolate that radical. I'm going to add 2 to both sides, so I get 2x minus 3 equals 3. Right? Add 2 to both sides, 2 and 1 is 3. Now, the radical's isolated to one side of the equation. I can now raise both sides to the index. Well, the index is 2, so I'm going to raise both sides to the power of 2. What I do to one side, I do to the other. When you square a square root, you essentially get what's under the radical, and 3 squared is 9. Now, this is a problem that I can go ahead and solve. See what I get. Add 3 to both sides, and divide by 2, x equals 6. Check your answer, especially when it comes to radicals. Let's see in the original equation if that's a true statement. 2 times 6 is 12. 12 minus 3 is 9. The square root of 9 is 3. 3 minus 2 is, in fact, 1. So this does work. I know it's the solution. I've checked it. All right, next example. All right, cubed root, a little bit different, but our steps are still going to be the same. I want to isolate the radical, so I'm going to add 3 to both sides. And by doing that, I get the cubed root of x minus 2 equals 3. Now I'm going to raise both sides to the power of the index, which is 3. I'm going to cube both sides. What I do to one side, I do to the other. So cubing a cubed root, again, just gives me what's under the radical. That's our tool to eliminate that radical. And 3 cubed is 27. And now I can solve it, add 2 to both sides. X equals 29. Let's check our work, make sure we got it. 29 minus 2 is 27. The cubed root of 27 is 3. 3 minus 3 is 0. That's a true statement. I checked my work. I can't be wrong, which is a nice feeling. Let's look at this one. The cubed root, or excuse me, the square root of x minus 8 plus 2, I'm going to subtract 2 from both sides. And I'm going to stop right here. Because what I know about square roots is they're always positive. Hopefully we recall that from the very first section when we talked about radicals. The square root of the radical has to be positive, right? There's no value that's times itself that's going to be negative, because a negative times a negative is a positive. So there's no value that's going to give me a negative. The answer to this is there is no answer. It's no solution. Or we could just write our null set. Now, if we tried to continue on, and this is why it's so important, if we didn't recognize this and jump to no solution, if I squared both sides, I'll just do it right here, I'd get x minus 8 equals a positive 4, because negative 2 squared is a positive 4. And then I could subtract 8 from both sides, and I'd get negative 4. Oh, x is negative 4. That's my answer. No, if we check that, negative 4 minus 8 is negative 12. Right? Did I? Oh, I'm sorry. I went the wrong way here. If I add 8, sign error, we're all guilty of that one. If I add 8, we get 12. So if I put 12 in there, 12 minus 8 is 4. The square root of 4 is 2. 2, a positive 2 plus 2 is not equal to 0. So this does not make a true statement. So we can see if we worked it out, sign error or not, we're not going to get a true statement. Either way. All right? What if we have additional radicals? What if we have more than one radical in an equation? Don't panic. Just take your time. Essentially, follow those steps. We want to isolate a radical. Just pick one and isolate it, and then go through the steps. If there's still a radical that remains, start over. Let's isolate that radical and work through it. So this problem is going to be a little bit longer and tedious, but we're going to work through it. I'm going to isolate this radical. Essentially, add this value to both sides. So I'm going to get the square root of x plus 7 equals 2 plus the square root of x minus 1. So I just added it to both sides. Now, I can square both sides because my index is 2. And hopefully we recall from the previous section how to deal with something like this. Treat it just like a binomial. We're going to multiply it by itself, do a little bit of FOILing. Here, if we square the square root, we just get that value. This is not equal to 4 plus x minus 1. We have to actually FOIL it out. It's this value times itself. So if we do FOIL that out, we're going to get 4 plus 4 square root of x minus 1. That's my inner and outer terms combined. Plus the square root of x minus 1. Oh, no, we're squaring that last term. Sorry about that. And we can see, well, there is some like terms we can deal with, so we'll work through that. We have an x on both sides. They cancel out. If I subtract x from both sides, it's gone. And let's see, I have a 4 minus 1 is 3. I'm going to subtract 3 from both sides, right? And if we see that, we get 4 equals 4 square root of x minus 1. Now, just by doing that, combining our like terms, we can see, hey, guess what? I still have a radical. But one nice thing is it's on one side all by itself. Maybe I can do something with this 4. I don't have to, but I can. I can say, hey, these are both divisible by 4. Let's divide that out. And we get 1 equals the square root of x minus 1. If I square both sides here, well, 1 squared is 1. This squared is x minus 1. Add 1 to both sides. and I get 2 equals x, or if you prefer, x equals 2, well, the order here doesn't matter. Is this a true statement? Does it work? Is this the value I was looking for? Well, let's go back and check it. But before we do, let's just review. We isolated a radical, raised both sides by the index. Then we did what we had to do here. We combined like terms to get the radical by itself, because it still contains a radical. And then we started over. Let's isolate the radical. Let's raise it to the index and solve like we normally would. Now we're at the point where we can actually check it. If I plug 2 into here, 2 plus 7 is 9. The square root of 9 is 3. I'll write it up there. If we plug 2 into here, we get 2 minus 1 is 1. The square root of 1 is 1. So we have 3 minus 1 equals 2. Well, that's pretty true, ain't it? It doesn't get much more truer than that. 3 minus 1 is 2. So that's true. So I've checked my answer, and I know x is 2. All right, this one's a good problem because it reviews what we've talked about in previous sections. When we have fractional exponents, that's the same thing as a radical. So if we want, we could rewrite this. Well, this is just saying the cubed root of x. X to the 1/3 power is the cubed root of x. Minus 2 equals 4. So that's good review from previous sections. Make sure you remember fractional exponents are nothing more than radicals. X to the 1st power, the numerator, the index of the radical is the denominator, the cubed root. And now we can use our process before. We're going to isolate the radical by adding 2 to both sides. And then we can cube both sides, raise it to the power of the index. And 216, I believe. Let's see. Is that right?
I think so.
All right. Well, maybe I made a math error. Maybe I didn't. Let's check our answer. Well, if we take the cubed root, or 216 to the 1/3 power, do we get that? Does this factor down to 3 factors of 6? Well, let's find out right here. Does this factor down to 3 factors of 6? Well, 6 goes into 21 3 times with a remainder of 3, right? 18, yep. And 6 goes into 36 6 times. So, yeah, 36 and 3, and we know that this is 2 factors of 6, so sure enough, it's 216. So the cubed root of 216 is 6. 6 minus 2 is 4. So we checked it. We know that this works. Kind of a weird way to check it, but that's sometimes the way I do my math. All right, well, that's how we work with equations dealing with radicals. Just to review, we isolate a radical, we raise both sides to the index, we solve, and then we check our work. If a radical remains after we solve, or excuse me, after we've raised both sides of the index, re-isolate it, raise it to both powers, solve it, and then check the answer in the original equation. So that's how it's done for section 6.4, equations containing radicals. Thank you.